There are three kinds of braking used in a SureServo 2 system. Dynamic braking, which is used to stop the motor quickly when you disable the motor, issue an override, or get a fault. Regen braking, which is used while the motor is running to help create super fast deceleration ramps using a regen or braking resistor. And electromechanical braking, which is used while the motor is stopped to keep it from spinning. This video covers dynamic braking. When you try to slow down a motor faster than it would normally spin down by itself, the motor becomes a generator and pushes current back into the drive. That raises the internal bus voltage, and if that voltage gets too high, it can damage the internal components. The drive won't let that happen, of course. It'll fault out and shut down before anything bad happens. Dynamic braking watches that bus voltage and dynamically adjusts the decel ramp so the bus voltage doesn't get too high. It's important to understand that dynamic braking in a SureServo 2 drive doesn't use a regen resistor to dump excess energy. It only modifies the decel ramp to slow down the regen current. Regen braking is covered in a separate video. This is easiest to see with a live example, so let's do it. This is the exact same hardware as the quick start video, except I added this 4-pound steel pulley to give us some inertia. I reset the drive to factory default so you know exactly where I'm starting from, and I power cycle the drive. That clears out any residual non-volatile memory locations. I then changed it to speed mode and power cycle the drive again. That power cycle is real important because it sets up the drive for the new mode. And here's a tip. If you can't get the motor to spin after a mode change, it's probably because you forgot to do the power cycle. In speed mode, you can set up 2 digital inputs to select one of 4 preset speeds. I'm using digital inputs 9 and 10 for that. These are the default speeds, but I changed this one to 3000 RPM and set the 2 digital inputs to on, so when I enable the servo motor, it ramps immediately to 3000 RPM. And when I disable the motor, or issue an override, or get a fault, the drive drops to 0 from this 3000 RPM. These are the parameters you need to do all of that. Let's bring up the SureServo 2 Pro software scope function. I'll hit run, and while we're waiting for that to come up, we see we're viewing the commanded speed in white using 32 bits, so it uses 2 of these, the actual motor speed in purple, also using 32 bits, the bus voltage in red, and the motor current in yellow. When I switch the servo on, the white commanded speed goes right to 3000 RPM, and the purple actual speed follows that as best it can. I haven't tuned this drive yet, so we have a bit of overshoot. Watch this video to learn how to fix that. When I disable the motor, the white speed command goes straight to 0, and we see dynamic braking is working really hard to bring the purple actual speed to 0 with no alarms or errors. And it did a pretty good job. I'll stop the scope, and if we zoom in on the decel ramp, we see that dynamic braking was able to get that heavy load close to 0 RPM in around 400 milliseconds and fully to 0 in around 600 milliseconds. Cool. We also see while the motor is running at 3000 RPM, the bus voltage hangs around 170 volts on this drive, and the current needed to keep the motor spinning is only a couple tenths of an amp. But when we switch the motor off, the red bus voltage rose from around 170 volts to 190 volts because the motor pushed the yellow current of almost 5 amps back into the drive. The minus sign tells us the current is going back into the drive, and we can see the negative current here in yellow. I'm going to hit this button, which maximizes each trace and gives it its own scale so everything's easier to see. Again, the white commanded speed went to 0, the motor pushed the yellow current back into the drive, which raised the red bus voltage, and dynamic braking manages the decel rate to keep that voltage from getting too high. My nominal bus voltage is around 170 volts because I'm using a 120 volt supply. If you have a 220 volt supply, then this will be around 312 volts. Let's swap out the 4-pound pulley for a 2-pound pulley. This will have less than half the inertia, so let's see how dynamic braking handles that. Let's start the scope. I'll switch the servo on, wait a second, and then switch it off, and stop the scope. Zoom in on the decel ramp, and sure enough, we now see it's only taking dynamic braking around 100 milliseconds to get close to 0, and a total of less than 200 milliseconds to completely stop. And if we optimize that display, we can see dynamic braking is still allowing almost 5 amps back into the drive, and it's still allowing the bus voltage to go up to 190 volts. But it's taking full advantage of that to get a faster decel ramp. Nice. Of course, you can also disable dynamic braking. I'll go to parameter 1.32 and change this to a 1 to disable braking. I also switched back to the 4-pound pulley to give us a more dramatic result. I'll start the scope, switch the motor on, and then switch it off, and I'll speed up the video so we don't have to wait for it to spin down. Wow, it looks like it took that around 14 seconds for the motor to spin down without dynamic braking. Compare that to the half second we had with dynamic braking. So yeah, dynamic braking makes a big difference. And look at this. If we zoom in on the white speed command transition from 3000 to 0 RPM, we see there was no impact on the current or the bus voltage because we weren't trying to force the motor to stop. So the motor didn't become a generator trying to shove current back into the drive. So we can turn dynamic braking on and we can turn it off to let the motor free spin. Well, guess what? There's a third mode that does both. It uses dynamic braking down to a certain speed and then releases the motor to free spin the rest of the way. You put whatever cutoff speed you want in parameter 1.38. I put 200 RPM in for the cutoff speed and ran that test. And this is what I got. Braking down to here, free spin afterwards. It also sets the 0 speed output bit once it hits this level so other processes know it's safe to do their thing. Again, that may be handy for applications where you just need to get the dangerous speeds shut down as fast as possible and don't really care about getting it exactly to 0. Well, that should give you a pretty good feel for how the dynamic braking built into the SureServo 2 drive works. Understand that dynamic braking is only used when you disable the motor, when you issue a motor override via a digital input, or have a fault. The normal decel ramps in the various operating modes use the braking or regen resistor to automatically accomplish whatever decel ramp you ask for, assuming the drive and resistor can handle it. We'll cover that in this video. Click here to learn more about the SureServo 2 drive and to find more videos like this one. Click here to subscribe to our YouTube channel so you'll be notified when we publish new videos like this, and click here to learn about Automation Direct's free award-winning support options.